So it's Mr. Rops here, and we are working on differential equations today. So I know the rate at which water flows out of a bucket is proportional to the square root of the volume remaining in t hours. Initially, the bucket contains 100 liters. After 2 hours, there's 25 liters remaining. Solve an expression for V as a function of t. Well, there's a lot of words here. I have to make sense of it. So a couple things going on. The rate at which the water flows out. So the water flowing out is going to be the volume. So I know that dV dt is proportional to the square root of the volume remaining. So proportional, so it's going to be proportional, some constant of proportionality times the volume, the square root of the volume. And because it's flowing out, I know it's going to be negative. If I don't put the negative there, I can just solve for k, and k will end up being a negative value as well. But I like to think about me being in charge of the negative itself, thinking it through. So here's my differential equation. And I can see that v is out here, and this is v over here as well, and k is constant. But I know the initial bucket, so when t equals 0, the volume is 100 liters. And when t is equal to 2 hours, the volume is equal to 25. And I need to end up with v is equal to stuff with t is what I'm actually trying to do overall. So when I do this, I can see there's t here and there's v here. Typically back in the past when we were doing derivatives, it would be, oh, x squared kind of thing. But now we have this function here on the right is in terms of v is this function on the right. And so this here is a situation that is similar to that we have to do separable differential equations. So I'm going to move the v to the 1/2 power. I'm going to multiply by v to the 1/2 both sides. And I'm also going to move that dt. So I'm going to do the integral of 1 over v to the 1/2 dv is equal to negative k, the integral of dt. Okay, so I move the dt up, I move the v over, and I pulled the constant out, and so there's just a 1 here. I'm going to rewrite this function here as f to the minus 1/2. Okay, and so now the left-hand side of the equation in terms of v, the right-hand side of the equation is in terms of t because k is just some number, not a function. So now I actually go ahead and I integrate this. So when I integrate this, I know I add 1 to the exponent and I multiply by the reciprocal. And that is going to equal to negative k. The integral of 1 is going to be t plus some constant value c. And so now I have two functions to find. I need to find, or two values to find, k, and I need to find c. So let's start with the initial value. When t equals 0, the volume is 100 liters. So 2 times 100 to the 1/2 is equal to negative k times 0 plus c. Well, that's just 0. And so the 100 to the 1/2, the square root of 100 is 10 times 2 is 20 is equal to c. So now I know that it's 2v to the 1/2 is equal to negative kt plus 20. Using the second bit of information here, t is 2 and v is 25. So when I make t is 2 and v is, as I said, was 25. And so 25 to the 1/2 is 5 times 2 is 10 is equal to minus k times 2 plus 20. Subtract the 20, I get negative 10 is negative 2k, and so k is 5. So now if I put this all together, I get 2 to the 1/2. Here's I'm looking at the 2 to the 1/2 is equal to minus 5t plus 20. And so the question says to solve an expression for v in terms of t. So I need to now solve for v. So I'm going to divide by 2. Equal to negative 5 over 2t plus 10. Each term gets divided by 2. and then I'm going to square it. V is equal to negative 5 halves t 10 to the power of 2. And this is my relationship of v, function v volume, in terms of t time. And so we separate our variables, and we use both bits of information to find the constant proportionality and c. I do think reading this problem here and coming up with this equation, the dv dt equal to negative k v1 half, this is a challenging step. You have to make sure you read that carefully to come up with what it is saying.